Lesson 2.2. Our objective is to solve equations using the multiplication and division properties of equality. Coefficient. In a term that is a product of a number and a variable, the number is the coefficient of the variable. For example, in the term 2x, 2 is the coefficient. Reciprocal. If a over b is a non-zero number, then b over a is its reciprocal. Multiplication property of equality. If a is equal to b and does not equal 0, then c times a is equal to c times b. This means that you can multiply the same non-zero number to both sides of an equation and still have an equivalent equation. Division property of equality. If a is equal to b and c is different from 0, then a over c is equal to b over c. This means that you can divide both sides of an equation by the same non-zero number and still have an equivalent equation. Rules for solving equations. Number 1, your goal is to isolate the variable on one side of the equal sign. Number 2, always perform the same operation to both sides of the equal sign. And number 3, to undo an operation, perform its inverse operation to both sides of the equal sign. In this lesson, we're going to learn how to solve equations using multiplication and division. Example 1. Use the division property of equality to solve the equation. Well, the first equation that I have in this example is 8x equals 56. Well, this term 8x, that is the same as saying 8 times x equals 56. So this is a multiplication problem. 8 times some number equals 56. Well, when I'm solving an equation, I know that my goal is to isolate the variable. So if I'm going to isolate the variable, that means I need to get rid of this 8. And we're going to use inverse operations in order to do so. So let's go ahead and get started. First thing that I'm going to do, I'm going to draw my little line down, separating my equation into two separate parts. I have my left side and I have my right side. Remember, when solving equations, whatever you do to the left side, you have to also do the same thing to the right side in order to keep an equivalent equation. So once again, this is 8 times the variable x. 8 times the variable x. So the inverse of multiplication is division. So in order for me to get rid of this 8, I need to divide both sides by 8. So that's what I'm going to do. I'm going to divide by 8, divide by 8. 8 divided by 8 is just 1. So I'll bring down what I have left. 1x equals 56 divided by 8 is 7. So I have 1x equals 7. Well, it's not wrong for me to write the 1, but it's not necessary for me to write the 1 either. So I think I'll rewrite this as x equals 7. There's no need for me to put the 1 in front of the 7. It's understood when you don't see a number in front of the variable, it's understood that the coefficient is 1. So now if I want to check my solution, I'm going to substitute the 7 for the x in the original problem. If it's the correct answer, it should equal 56. So that becomes 8 times 7. Well, 8 times 7 is indeed 56. So I know I have the correct solution. Let's check out the next one. For this one, I have 4x is equal to 128. I'm going to start the same way. I'm going to draw my line down, separating my equation into two parts. I have my left side and my right side. I know that the goal is to isolate the variable, so that means I need to get rid of the x. I need to get rid of the 4. So I need to get rid of this coefficient 4, and this means 4 times the variable x. Inverse of multiplication is division, so that means I'm going to divide by 4. I'm going to divide by what I'm trying to get rid of. So whatever you're trying to get rid of, that's what you divide by. 4 divided by 4 is just 1. I'll bring down my x. It's understood that there's a 1 there, so there's no need for me to write the 1 in front of the x. And this gives me 128 divided by 4. 128 divided by 4 is 32. So that means x is equal to 32. So if I want to check my answer, I'll replace the x with 32 in the original problem, and it should equal 128. So that becomes 4 times 32. Multiply 4 times 32, and it does give you 128. So that lets me know that my solution is correct. The last one, start off the same way. Draw my little self-align, dividing my equation into two separate parts. My goal is to isolate the variable. This time, I'm trying to get rid of the coefficient 7. So that means that I need to divide both sides by 7. 7 divided by 7 is 1. So I'll bring down my x, bring down my equal sign, and once again, 84 divided by 7 is just 12. So that means the solution to the equation is x is equal to 12. If I want to check my answer, I'll replace the x with the 12 from the original equation. And if it's correct, it should equal 84. Well, if you multiply 7 times 12, it does indeed give you 84. So that means that my solution is correct. And that's my final answer. Example 2. Use the multiplication property of equality to solve the equation. The multiplication property of equality tells us that we can multiply both sides of an equation by the same non-zero number and still have an equivalent equation. So that's what we're going to have to do in order to solve these problems in example 2. Let's take a look at the first one. I have x over 6 equals 8. This is the division problem. I have the variable x divided by 6 equals 8. So I know my goal is to isolate the variable. My goal is always to isolate the variable. So in this particular case, that means that I need to get rid of this 6 in the denominator. And since a fraction is nothing more than division, the inverse of division is multiplication. So to undo this problem, I have to multiply both sides by the same non-zero number. I'm going to start off the exact same way as I did before. I'll draw my little line dividing my equation into two separate parts. I have the left side of my equation and the right side. Remember, when solving an equation, whatever you do to the left, you have to also do the same thing to the right in order to keep it equal. We have to be fair. So, my goal is to isolate my variable, so that means I need to get rid of the 6 in the denominator. So I do that by multiplying both sides by 6. I'm going to multiply both sides of my equation by 6. On the left side, 6 divided by 6 is just 1. So I bring down what I have left is x. My 6 is canceled out. Bring down my equal sign, and then 8 times 6 is 48. So that means that the solution to my equation is x is equal to 48. If I wanted to check my solution, I'd simply substitute it into the original equation, and it should equal 8 when I work it out. So that becomes 48 divided by 6, and 48 divided by 6 is 8. So that lets me know that I have the correct solution. Same thing on my next one. I have the variable x divided by 4 equals 12. Start the same way. Going to use my little line to divide my equation into two separate parts. Now my goal once again is to isolate my variable. So that means I need to get rid of this 4 in the denominator. Once again, the way I do that, I want to do the opposite of division. The opposite of division is to multiply. So if I'm trying to get rid of the 4 in the denominator, it means I need to multiply both sides by 4. 4's cancel out, bring down my x, bring down my equal sign, And then times 4 gives me 48. So that means that the solution is x equals 48. If I want to check my solution, replace it in the original equation. So that becomes 48 divided by 4. 48 divided by 4 is 12. Since it checked out, that lets me know that I have the correct solution. And then the last one, I'm going to do the same thing. Start off with my line, trying to isolate my variable, so that means that I need to get rid of this 3 in the denominator. So I'm going to do the opposite of I'm going to do the opposite of division, and that means that I'm going to multiply both sides by 3. I'm going to multiply both sides of my equation by 3. 3's cancel out, bring down my x, bring down my equal sign, and negative 10 times 3 gives me a negative 30. So the solution is x equals negative 30. Check my solution. I'm going to replace that x with negative 30. So this becomes a negative 30 divided by 3, and it does give me a negative 10. So it checks out. I know I have the correct answer, and that's my final answer. Example 3. Use the multiplication property of equality to solve the equation. For each one of these problems, in example 3, if you look at them, the coefficient is a fraction. So with this example, you're going to learn how to solve an equation when your coefficient is a fraction, how to get rid of that fraction. Because we know the goal is always to isolate the variable. So it means we're going to need to get rid of this fraction. Okay? So let's go ahead and get started. I'm starting off the same way as I did in my previous problems. I'm going to draw the line to separate my equation into two separate parts. I have my left side and my right side. My goal here is to get rid of this 2/3. The way you do that, we're going to multiply both sides of our equation by the reciprocal of 2/3. And the reciprocal of 2/3 is simply 3 over 2. To get the reciprocal, you simply interchange the numerator and the denominator. Now remember, if you do it to the left, you have to also do it to the right. So on the right side, I'm also going to multiply by 3 over 2. Now back over here on the left, when I multiply 3/2 and 2/3, to multiply fractions, you simply multiply the numerators, multiply the denominators. It's going to give me 6 over 6, which is just 1. So it actually cancels itself out. So I bring down what's left. I bring down my x. Because I know I don't have to keep the 1 as my coefficient. It's understood that there's a 1 there. Now when I get to multiply, get ready to multiply 8 times 3/2. I don't know if you have trouble with fractions, but I'm going to show you two different ways to multiply this. So if I were to multiply 8 times 3/2, I'm simply multiplying the whole number times the numerator. 8 times 3 is 24, and I keep the denominator, which is 2. Now I'll reduce. 24 divided by 2 is 12. So 8 times 3/2 is 12. Now the way I like to do it is actually the same way. The only difference is I reduce before I get started. What I look at the whole number and the denominator, and I see if I can reduce before I get started. Well, I know that 2 will go into 8 4 times. So this becomes 4. And 2 will go into 2 1 time. So this becomes 1. Now I can multiply my whole number 4 times 3, which gives me 12. Keep the same denominator, which is now just 1. So my answer is still 12. Only difference is I reduced before I got started. The reason I like to reduce before I start is because sometimes your numbers can get a little large, and then that's just extra work. Okay? So now I know that 8 times 3 halves is simply 12. So my solution is x equals 12. Now I still want to check my answer. The original equation was, excuse me, not 3, but 2/3 x equals 8. I'm going to replace the x with 12, and it should equal 8 if I have the correct answer. Now once again, I have to simplify this, and I know how to multiply a whole number and a fraction. I'm going to reduce before I get started. I'm looking at the whole number and the denominator. I know that 3 will go into 12 4 times. So this becomes 4, and 3 will go into 3 one time. So now I can multiply my numerator times the whole number, which is 8. Keep the original denominator, which is not the original denominator. Keep the new denominator, which is now 1. So that just becomes 8. Left side equals the right side. So I know, hey, 12 was actually the correct answer. So my correct answer is x equals 12. Let's check out the next one. Now I have 2/5 x is equal to 14. I think I'll go ahead and rewrite this one over just a little bit because I'm so close to that line. 2/5 x equals 14. Do the same thing. I need to get rid of this fraction. Once again, I multiply by the reciprocal. The reciprocal is simply interchanging the numerator and the denominator. I have to do that to both sides. Okay, becomes 1. This becomes 10 over 10, which is just 1. So I'll go ahead and bring down what's left. I have x equals 14 times 5 halves. I look at the whole number and the denominator, and I see if I can reduce, and I can. 2 will go into 14 7 times. 2 will go into 2 one time. Now I can multiply the whole number times the numerator. 7 times 5 is 35, and the denominator is 1. So that means that the solution is simply 35. We don't need to keep that 1 as the denominator. I do want to check my solution, so I'll come down here and I'll check. The original equation was 2/5 x equals 14. I'll replace that x with a 35, and that should give me 14. Once again, I'll reduce before I start. Can I simplify 35 and 5? Yes, because 5 will go into 35 7 times. 5 will go into 5 one time. So now 2 times 7 is 14. It's just going to be 14 over 1. I have 14 equals 14. So that lets me know that I have the correct solution. And the correct solution was x equals 35. Now let's look at this last one. I'm starting off the same way, drawing my line. I'll draw my line down. I'm getting rid of this negative 4 over 5. The reciprocal of negative 4 over 5 is negative 5 over 4. Do not forget to watch your signs. Do that to both sides of my equation. Negative 5 over 4 cancels out on the left. Bring down my x on the left. Bring down my equal sign in the middle. I look to see whole number and denominator. I'm looking to see if I can reduce, because this is really saying like 20 over 4, 20 divided by 4. Well, 4 will go into 25 times. 4 will go into 4 one time. Now I'll multiply 5 times negative 5. That gives me a negative 25. My denominator is 1. I really don't need to write the denominator if it's 1. So my final answer is x equals negative 25. I'll go over here and check my solution. The original, -4/5, x equals 20. I'll replace that x value with -25. Okay? Should equal 20. Now what am I looking at to reduce before I get started? The denominator and the whole number. Well, 5 will go into 25 5 times. 5 will go into 5 one time. So what do I have left? That gives me -4 times a -5, which is a +20. My left side does equal my right side. So that lets me know that that solution that I had, that -25, is the correct answer.